Good morning, welcome back. We are now studying the evolution of stars, under which we first study how a star will be born. During random motion of hydrogen atoms in space, at certain stage, they begin to converge to some point. Then there will be a small gravitational force of attraction between these hydrogen atoms, which are spread over trillions of kilometers. And if this attraction is strong enough, then the atoms will not fly away. Then they will form a packet of gas. And in such a packet, there will be about 10 power 57 atoms, and these hydrogen atoms will be held under their own gravity. Such a packet of hydrogen atoms consisting of 10 power 57 atoms forms the beginning of a star, and that beginning of a star is called the protostar. Because of the gravitational pull towards the center, the protostar continues to reduce in size. The temperature of the star will begin to increase from 100 Kelvin to 50,000 Kelvin in about a year because of the shrinkage of the protostar, because of the contraction of the protostar. And the protostar now becomes luminous. And this contraction of the protostar is so rapid in the beginning, and after about 10 million years, a protostar will contract from its original size of trillions of kilometers to about 2.5 million kilometer in diameter. And the internal temperature of the protostar will then be about 10 million Kelvin, and at this particular temperature, the nuclear fusion reaction begins. The fusion of hydrogen to form helium with the liberation of energy will begin at this temperature. And now a star is said to be born. The surface temperature of such a newly born star will be about 3600 Kelvin. And in this slide you can see here, this is the hydrogen cloud which is spread over trillions of kilometers. There will be gravitational attraction and it forms a protostar, and it takes some billion of years or from million of years to form or to initiate what is known as the thermonuclear reaction. When once the fusion reaction initiates, the star is said to be born, and when the star is said to be born, it appears on the main scale. Now coming to the maturity, the temperature and luminosity of the star increases as the nuclear energy released at the center increases. As more and more number of hydrogen atoms fuses to form more and more helium atoms, the temperature as well as the luminosity of the star increases. During nuclear fusion, hydrogen will be continuously converted to form helium with the release of large amount of energy, and such energy released in the core of the star balances the inward gravitational force. And such energy which balances the inward gravitational force is called the outward thermonuclear energy. And when these two energies are balanced, then the star will remain in the main sequence, and the star is said to be in hydrostatic equilibrium. When these two forces, the outward thermal pressure due to the nuclear energy, the outward thermal pressure due to nuclear energy, and the inward pressure due to the gravitational force, when these two balances, the star is said to be in the hydrostatic equilibrium. When the star is in hydrostatic equilibrium, it appears on the main sequence of the HR diagram. So here we can see that star of different masses First one is 0.5 times the solar mass, and the second one is equal to the solar mass, and the third one is 3 times the solar mass, 9 times the solar mass, 15 times the solar mass. As the mass of the star increases, it appears on the main sequence as shown in figure. Lower the mass of the star, it appears in the lower part of the main sequence. Higher the mass of the star, it appears on the upper part of the main sequence. And also it is shown that the time taken for the star to form. If larger the mass of the star, lesser will be the time taken to form the star. You can see here, if the mass of the star is 15 times the solar mass, the time taken will be about 60,000 years. If it is 9 times the solar mass, then the time taken to form the star, or the time taken to appear on the main sequence, is 150,000 years, and so on. Larger the mass, lesser will be the time taken to form the star. Lesser the mass of the star, larger will be the time taken to form the star and to appear on the main sequence. Now coming to the aging stars. The helium produced by the fusion of hydrogen will collect at the center. After the complete fusion of hydrogen in the core, then there will be no burning of hydrogen at the center, and the core is said to be completely filled with helium. And such a helium core will begin to contract under gravity, and thus the core becomes hotter, and the core heats up the hydrogen surrounding the core, and this hydrogen blazes more brilliantly, and this radiation will be absorbed by the hydrogen in the outer layers of the star, because of which the outer layers will expand in the outward direction, and hence the size of the star increases, because of which the luminosity remains the same, but the amount of energy radiated per unit area decreases because of the increase in size of the star as the outer layers expands. Hence, the surface temperature of the star is said to be decreased. Now the star appears red in color. The helium core continues to contract as the envelope can no longer absorb the radiation. It escapes from the surface and the brightness of the star decreases. The star now becomes a red giant. The star becomes a red giant. Thank you.